All right, let's just jump right into this explainer. If you've been anywhere near tech news lately, you've definitely seen the massive headlines about India's highly ambitious push to build microchips domestically. And look, it's a huge deal, but honestly, there's a lot of noise and political grandstanding out there right now. So today, we're going to cut right through all of that. We're looking strictly at the hard data, the actual hardware, and the underlying strategy behind what could be a massive technological leap.
I mean, just look at the sheer scale of the numbers we're talking about here. $11 billion. That's roughly 91,000 crore rupees that has been officially committed to building a semiconductor fabrication plant, or a fab, in Dholera, Gujarat. And this is a massive joint effort, right? We're talking Tata Electronics teaming up with the Dutch equipment giant ASML and Taiwan's PSMC. To put it simply, this isn't some small experimental pilot project. It is a giant financial stake planted firmly in the ground.
And it's not just an economic move either. It's truly a 0-to-1 moment. Like Tata Electronics CEO Dr. Randhir Thakur said, this really is a historic milestone. The ultimate goal here is nothing short of transforming India from a consumer of global technology into a global manufacturing powerhouse. Think about it. For decades, India has written the software code that runs the world, but they've always had to import the physical hardware that actually runs that code. This new fab is the very first major step to changing that dynamic forever.
So, let's actually map out this 0-to-1 moment and see what's going on under the hood.
You're going to hear this new facility referred to as a 300mm fab a lot. But what does that actually mean for us? Well, a 300mm wafer is basically the size of the pure silicon dinner plate that the microchips are actually printed onto. And the Tata facility is targeting a wildly impressive output of 50,000 of these plates every single month. But here's the catch. While both the absolute bleeding-edge fabs and this new Tata facility use the exact same 300mm wafers, the physical size of that plate doesn't actually dictate how powerful the chip is.
Which brings up the whole 28nm versus bleeding-edge debate. Okay, so understanding nanometers is absolutely crucial here. You can kind of think of chip process nodes like camera megapixels. A smaller nanometer number generally means you can pack way more transistors onto the chip, giving you much higher computing performance. This new Dholera fab is targeting 28nm to 110nm nodes. Going back to our camera analogy, these are basically your 8-megapixel cameras. Are they the crazy 4K resolution you see on flagship phones? No, but they are incredibly reliable, perfectly useful, and literally essential for a huge chunk of everyday tasks.
And the contrast in the global market right now, it's honestly pretty stark. India is building a really solid foundation for what the industry calls mature nodes. These chips cost around $4,000 per wafer, and the demand is booming. They're the absolute essential brains inside electric vehicles, 5G routers, smart power grids, even your washing machine. Meanwhile, the world's bleeding-edge nodes, down in that 2 to 5 nanometer range, those cost upwards of $30,000 per wafer. Those are the chips powering global AI and top-tier smartphones. So India is jumping into the market, but they're doing it smartly at the mature node level, not trying to fight at the bleeding edge right out of the gate.
But here is where we hit a bit of a speed bump, the AI compute gap.
Because right now, there is a massive mismatch happening. See, India is aggressively building out this automotive and industrial chip hub at 28 and 40 nanometers. But if you want to train massive AI models, say a localized Tata GPT for instance, you desperately need 3nm and 5nm advanced compute chips. And those, they're currently made by foreign giants like TSMC for designers like NVIDIA. India just cannot manufacture them domestically yet. The result is kind of split. Domestic supply for everyday electronics is finally getting secured, but the import dependency for critical AI infrastructure, that continues entirely uninterrupted.
So to feed this urgent, honestly insatiable demand for AI in the meantime, the India AI mission is stepping in. We're talking about a roughly 10,000 crore rupee effort, and they are moving fast to acquire over 38,000 advanced GPUs. They're specifically targeting top-tier tech like NVIDIA's Blackwell chips. But here's the kicker we just talked about. Every single one of these 38,000 highly advanced chips has to be bought from foreign suppliers.
And the temporary workaround they've come up with? It's essentially a rented GPU model. Think of it like a government voucher system. It allows Indian tech startups to rent these imported foreign AI chips at heavily subsidized rates, sometimes just 65 to 115 rupees an hour. Now don't get me wrong, renting compute power absolutely helps startups survive today and keeps innovation moving. But fundamentally, it still leaves India's digital nervous system highly dependent on a global supply chain for its most critical thinking power.
And that brings us face to face with the bottlenecks and the massive global competitors.
Because let's be real, buying the incredibly expensive manufacturing machines, that's actually the easy part. The real battle is completely structural. India is looking at a severe talent gap. They need over 250,000 trained semiconductor professionals by 2027. Plus, fabs require massive infrastructure, like 24/7 ultra-pure water and absolutely flawless power grids. Then you look outward at the competition. Vietnam has electronics tariffs sitting at 0 to 1%, while India is at 9 to 10%, making the assembly so much cheaper there. Add to that the fact that TSMC already owns about 92% of the global market at the sub-5 nanometer level, and China is gearing up to drop an earth-shattering $100 billion on fab equipment. The headwinds here are just incredibly fierce.
So, how do you bypass all that? Enter the semiconductor leapfrog strategy.
Experts are actually proposing this wild thought experiment. They're calling it the geo moment for chips. Think back for a second. India didn't spend decades laying copper landline wires trying to catch up with the West's telecom infrastructure, right? Instead, it leaped straight into 4G wireless and built the world's most penetrated mobile internet network. The big strategic question right now is, can India apply that exact same leapfrog logic to semiconductors? Can they just skip the impossible 40-year catch-up race with TSMC and find a totally new game to dominate?
And this leapfrog strategy basically boils down to 3 massive bets that completely reframe the narrative. Bet number 1, own the RISC-V design stack. That's an open-source chip architecture that skips heavy licensing fees. Bet number 2, corner the edge AI chip market. We're talking about those mature 28 to 7 nanometer chips that run AI directly on your smart car or your security camera, instead of relying on a distant data center. And bet number 3, become the world's OSAT capital. That stands for Outsourced Semiconductor Assembly and Test. This strategy flips the whole script from how do we catch up to how do we pioneer the next wave.
And the crazy part? We can actually see Step 3 happening right now in the real world. Micron's massive assembly and testing facility in Sanand, Gujarat is already 60% complete. We're looking at an investment of over 22,000 crore rupees. This is tangible proof that India can realistically become to chip packaging exactly what Vietnam is to electronics assembly, a super-fast, scalable, and highly critical node in the global supply chain. And the best part is, they can do it without needing those highly restricted $300 million lithography machines required for the bleeding-edge stuff.
But look, to achieve true technological sovereignty, an $11 billion fad is, literally, just the beginning of a multi-generational strategy. The data is super clear. India has to shift from just providing cheap design labor to actually owning global intellectual property. It's going to have to expand its full-stack talent pipeline by a factor of 10. We're talking about needing to target a massive $50 billion in cumulative fab investments by 2035, all while aggressively securing advanced tech access agreements for that 7-nanometer generation.
So, all of this data really leads to one perfect summary. The whole Tata ASML deal in Dholera, it's basically India's buying land in a new city moment. It is a vital, totally historic foundation. But we absolutely have to remember that just buying the plot of land isn't the finish line, right? It's literally just the prerequisite. It's the bare minimum required to start building the technological sovereignty the nation needs to actually survive and thrive in this coming AI revolution.
Which leaves us with one final, frankly provocative question to ponder today. Now that the ground has been broken and these massive initial investments are locked in, what is India actually going to build on this newly acquired technological land? Are we just looking at a modest trading post that assembles foreign components? Or will it actually rise up to become a self-sustaining metropolis that drives the future of global computing? The decisions they make in the next 5 years are going to give us that answer. Thanks so much for joining me on this explainer, and I'll catch you on the next one.